Hello everyone. In this lecture, I want to talk about how to present data on a map. Using maps to present data has become a new fashion in business analytics. All kinds of open source software like Python and R is offering this service to their users. You have different options in creating a map-based data report, but in my opinion, the RgoogleMaps package for the R software is very easy to use. So in this lecture, I want to teach everyone how to use the RgoogleMaps package. I want to create a sales revenue report on a map. I collected the geolocation data for the markets that are important to my company. I also collected the sales revenues my company made in those markets. Then I want to project the sales revenue data into the map by using different bubbles. For instance, if you look at Dallas, McKinney, and Denton, on top of these three markets, I have lighter brown bubbles. If you look at the legend in the upper left corner, a lighter brown bubble represents a sales revenue that is less than 1,600, but greater than 800. So if I look at the map, I will know my company made a sales revenue that is between 800 and 1,600 in Denton, McKinney, and Dallas. If you look at footwords, I have a bubble that has a darker brown color, right? If you look at the legend in the upper left corner, a darker brown bubble represents a sales revenue that is less than 3,200, but greater than 1,600. So if I look at the map, I will know my company made a sales revenue that is between 1,600 and 3,200 in footwear market. I want to use the RgoogleMaps package to create this report. I will also be using a source data file called sales revenue. You can download the source data in this video's description section below. Let's take a look at the source data file. As I just mentioned, we collected the geolocation data, latitude and longitude position for the important markets in the Dallas-Fort Worth metropolitan area. We also collected the sales revenues in those markets. Before we talk about the RgoogleMaps package, let's learn some geographical knowledge. If you look at a globe, we can separate the globe with a lot of vertical lines and horizontal lines, right? We call those vertical lines from the North Pole to the South Pole longitude. We call those horizontal lines that are parallel to the equator latitude. On a globe, for each place, it should have a longitude value and a latitude value. This is how we locate a place on a map. If you project the globe into a mathematical coordinate, then longitude should be the values that are changing on the x-axis. Latitude should be the values that are changing on the y-axis. If we separate the globe by using the center longitude line, we would have the eastern hemisphere and the western hemisphere. Every place in the eastern hemisphere should have a positive longitude value. Every place in the western hemisphere should have a negative longitude value. We can also separate the globe by using the equator. Then we would have the northern hemisphere and the southern hemisphere. Every place in the northern hemisphere should have a positive latitude value. Every place in the southern hemisphere should have a negative latitude value. If you search the geolocation data for a place by using search engines like Google or Yahoo, they will usually report the latitude data first, longitude data second. But as I just mentioned, longitude represents the values that are changing on the x-axis. Latitude represents the values that are changing on the y-axis. So if you process geolocation data in analytical software like R, you will use longitude data first, latitude data second. Please pay attention to this difference between the data reported by the search engine and the data you will be using in the R software. Now let's use the R software to create the map. First, we need to install the package. Let's type in the comment install.packages. Parentheses, between parentheses, let's type in 2 double quotes, and then type in the package name, RgoogleMaps. Please pay attention to the package name. R should be in uppercase, G should be in lowercase, M should be in uppercase. This is how it was defined, so we must use the package in this way. And then press enter. Let's choose the mirror side. Let's choose USA TX1 and then click OK. Now the package is downloaded into the R software. We are ready to create the map. First, let's start the package. Let's type in library, parentheses, between parentheses, let's type in 2 double quotes, and then type in the package name, RgoogleMaps. First, let's read the source data file into the R software. You need to download the sales revenue, this source data file, into your working directory. And then we want to import the source data into the R software. Let's create a variable. Let's call this sales. This variable will hold the source data. And then the less than sign and then small dash, and then type in rate.table, parentheses, and then we need to specify the 3 parameters. First, the source file name. It will be sales revenue.csv, and then a comma, and then SEP equals to 2 double quotes. Between 2 double quotes, we need to type in a comma, and then another comma after the double quote, and then type in header equals to T, and then press enter. Let's take a look at the data structure. Let's type in head, parentheses, sales. This is how the source data looks like. We have the city name, latitude and longitude for each city, sales we made in each city. Next, we need to create a map. Let's give this map to a variable as well. Let's call this sales map. This is a variable name. This variable will hold a map in the future. And then a less than sign and then a small dash. The function that can help us to create a map called the getMap. Notice that G and M are in uppercases. And then parentheses. Between parentheses, we need to give the values to some important parameters. The first parameter is called the center. Center equals to the longitude and the latitude values of the center point in your map. If you want to choose Dallas as the center point, then you need to look up the longitude and latitude values for Dallas, and then give these 2 values to center. When you give the 2 values to center, you need to do in this way. After the equal sign, let's type in C, and then another set of parentheses. In the inner parentheses, you want to type in LON equals to the longitude value for Dallas. I already looked it up, so let's just copy the longitude value and then paste into the inner parentheses, and then a comma, and then type in LAT. This represents the latitude value equals to the latitude value for Dallas. Let's copy the value and then paste it into the inner parentheses. This is the first parameter. After the inner parentheses, let's type in a comma. The second parameter is called a zoom. Zoom can be any positive integer, but if you want to zoom in the map, then you give a larger positive integer. If you want to zoom out, then you want to give a smaller positive integer to the zoom parameter. But usually, if you want to show a metropolitan area, you want to choose 8 or 9 as the value for the zoom parameter. Let's choose 9, and then a comma. The third parameter is called the size. Size equals to the length and width of the picture you want to finally generate. We should give the pixel values as the values for the size parameter. This is how. We want to type in C and then parentheses. Usually we want to choose 640 or 480 as the length and width of the picture we want to finally choose. Remember, these are the pixel values. Let's choose 480 as the value. So between the inner parentheses, let's type in 480 and then another comma and then type in 480 again. And then after the inner parentheses, let's type in another comma. The last important parameter we need to specify is the map type. Let's type in map type. If you want to show the regular map, you can use mobile as the value for map type. If you want to show a map with a more geological look, then you can choose terrain as the value for the map type. Let's choose terrain. After the equal sign, let's type in 2 double quotes, and then between 2 double quotes, let's type in terrain. This is how we specify the getMap parameters. Let's press enter. We didn't see anything because we haven't finished the map. Next, we want to create the bubbles on top of the map. The function name is called bubbleMap. Let's type in bubbleMap. Notice that M is in uppercase, and then parentheses. Between the parentheses, we also need to specify some important parameters. First, the variable that holds the source data. Currently, we give the source data to the variable called sales, so this will be the variable that holds the data. Let's type in sales, and then a comma. The second parameter is called coords. Let's type in coords equals to. When we give the values to the coords parameter, we need to look at the source data first and figure out which column holds the longitude values, which column holds the latitude values. And then we want to give the titles of these two columns as values to the coords parameter. After the equal sign, let's type in C and then another set of parentheses. Between the inner parentheses, we need to type in 2 double quotes. Looks like this column holds the longitude value. So let's type in the title of this column. Let's type in longitude. Notice that the letters and the cases should be as same as the title in the source file. And then between the double quote and inner parentheses, let's type in a comma. And then another set of double quotes. Then we want to type in the title of the column that holds the latitude data in the source file, right? This should be the title, latitude. L is in uppercase. So let's type in exactly the same name. Let's type in latitude. This should be the values for the coords parameter. Between the inner parentheses and the outer parentheses, let's type in a comma. The third parameter we need to specify is called map. Map equals to the variable that currently holds the map picture. We just create a variable called sales map to hold the map picture, right? So let's give a sales map to the map parameter, and then a comma. The next parameter we need to specify is called zcol, ZCOL, equals to the title of the column based on which we want to draw the bubbles in the map. At the beginning of this lecture, I showed everyone how we draw the bubbles, right? We look at the sales revenue in different markets, and then according to the sales revenue values, we draw different bubbles with different colors. So the sales should be the criteria based on which we draw the bubbles. We want to give the sales title, this title, as a value to ZCOL. Let's type in 2 single quotes. Notice that we type in 2 single quotes. This is how it was specified. So we must use ZCOL in this way. two single quotes. And then between two single quotes, we want to type in sales. This means we want to, based on this column, to draw bubbles with different colors. And then another comma. The last parameter we want to specify is called the key.entries. Let's type in key.entries. This is a very, very important parameter. Many people have a question about the values for key.entries. The values for the key.entries parameter should be intervals that can include all possible values in the sales column. These intervals must be able to separate all possible values in the sales column into different groups as well. For the instructional convenience, let me show you the source data in the Excel file. Let's take a look at the sales column. The smallest number in the sales column should be 330, right? The largest number should be 2,330, which means the lower limit of the interval must be less than 330 in order to hold the 330 into the interval, right? The upper limit must be greater than 2,330 in order to hold all possible values in the sales column. So how can we create an interval that can host all possible values, and also we can separate the interval into different groups? Let me show you first, and then I will explain. After key.entries, I want to type in equal sign, and then type in 100, and then an asterisk means multiply, 2, and then an up arrow. The up arrow key is the number 6 key on your keyboard. And then another set of parentheses. Between the inner parentheses, I want to type in 1:5. Can anyone tell me what I'm trying to do here? Yes, I want to use 2 up arrow 1:5 to calculate the 2 with a power of 1, 2 with a power of 2, 2 with a power of 3, 2 with a power of 4, and then 2 with a power of 5. And then I want to use 100 to multiply each critical value I just created. I want to use 100 to multiply 2 with the power of 1, then I get 200, right? And then I want to use 100 to multiply 2 with the power of 2, then I get 400, right? And then I want to use 100 to multiply 2 with the power of 3, then I get 800, and so on and so forth. So I'm able to establish some intervals. Then the bubbleMap function should assign bubbles with different colors to different intervals. If the sales revenue of a city falls into a particular interval, on top of that city, we want the bubbleMap function to draw the bubble with a particular color, just like what we saw at the beginning of this lecture. Many people have questions about the values for the key.entries parameter. Very important. If you don't give the right value, you are not able to draw the bubble map. You want to pay attention to 2 points of this value. First, the intervals you establish must be able to include all possible values in the drawing criteria. In our case, all possible values in the sales column. Second, you can use different base number when you establish different interval. You don't have to use 2 as the base number necessarily. You can use 3 or other numbers, doesn't matter. But no matter which base number you use, you must be able to separate the data range into different intervals. This is how you use the bubbleMap function. Let's press enter, let's see the final product. This is the final result.